So in this lecture, we will be talking about approach number 2. As we have seen that in approach number 1, the time complexity was order of n, but the space complexity was order of t. So in this approach, what we have done is we have tried to reduce the space complexity. In order to reduce the space complexity, the time complexity has been increased. So we will now look at our logic in approach number 2. So as I have discussed the problem statement in approach number 1, what we are trying to do is like if we have an array uh, and we have been given an input, that is d, that is the number of element that we want to rotate. So in this what is the explanation that I have given is, if we have an array, so we are taking a temp integer where we are storing the value of the element that is at index 0, and we are shifting the entire array. For example, for instance, like this 2 will be shifted to 1, this 3 will be shifted to 2, this 4 will be shifted to 3, this 5 will be shifted to 4, this 6 will be shifted to 7, and the 7, and we are not doing anything with 7, because if I will try to access 7, then the next value is null, and in this way the Java will throw an error of index out of bound. So this is how I am taking the value of index, the value that is present at index 0. Note that the index of an array start with 0. So what we have done is, after doing this shifting, we are taking the last index minus 1. So because if it's starting with index 0, so if the size is 7, so 7 minus 1, so this is what I have done over here, the last index minus 1, and the value that we have taken from here, we will putting it down over here. So we will be doing this thing again and again until the d, the number of shift that I want to do at the last of an array, is nullified. So here is our implementation. In public static void main, I have declared an array, and the size of d is 2 over here. So what I am doing is I have two different method, that is shift array and for printing of an array method. And in shifting of an array, what I am trying to do is like I am iterating from I is equal to 0 to I to the till d, that is the amount of element that I want to rotate. So once I take the initial element that is present at the beginning of an index, I have taken this method where I am shifting the array, and as I've said earlier, like I am doing till the size of array of length minus 1, because if I if I iterate it till this one, while accessing this, our Java the Java program will throw an error of index out of bound. So in order to avoid, and in order to even reduce the number of steps, I'm implementing this. And once I get an array, what I do is like I what the temp variable has, I append it to at the last. So in this way I am doing all the thing till what, till the size of the element that I want to rotate. So let's see what we have got in our output. So here you can see that it has been run successfully. So this is not the best method, but what we have tried to do in this one is like we have tried to reduce the space complexity, but while doing so we have neglected the edge cases of time complexity. That is why we are getting a time complexity of order of n into d. I would again like to have a glance over how it is being done, so because for this time complexity of order of d is taking place, but we have a method that we are rotating till order of n. So the time complexity will be order of n into d. Thank you, and in the upcoming tutorials we will see how the time complexity and the space complexity will be reduced, and how we are going to get an optimal solution. Thank you.